Okay, today we're going to continue with Earth engine data. So we talk about image and image collection on Monday. And today I'm going to talk about vector data, so geometry, feature, and feature collection. So make sure you practice. So after today, you should have a pretty good idea about the data type in Earth engine and how it relates to the data on your store locally. So you have image collection, basically a directory of images, and geometry is just the shape. Feature is a shape with attributes, and feature collection is a bunch of uh, features. And how we're going to filter the data, how you visualize the data, those are very um, essential skills that you need to have in order to be able to handle those big geospatial data. And also keep in mind there's no data format. Okay, so everything in Earth Engine is just things in the cloud. It doesn't have a shapefile, GeoJSON or something, GeoTIFF. It's just cloud. But one nice thing about cloud is the Earth Engine data is streaming the data is PNGs, just like you're seeing Google Map, Google Earth. So you can visualize a huge data set. I'm going to show you some examples later. You can visualize the entire US, for example, all the road network. And it's really fast. If you're doing locally, it's going to take you a while. So this is something that you might want to use. You can easily do all kind of analysis with that. So I'm going to go to here. We're going to start with the geometry. And let me run this one here. Oops. Okay, so run this one here. And like I said, everything in Google's engine is a server-side object. It's going to start with something e-doc something. So I would recommend that you check out the Google Earth Engine website. Just able to learn more about that. So if you go to references or you go to get started, this should give you more information. You can also read the book of the GMAP book. It should give you some loads. But on the left side here, object and measures. Okay, geometry, feature and feature collection. So these are some of the critical ones. Some of the example in the book actually come from here. And the other one you can look at is if you go to the reference tab here on the website, and then on the left side, client libraries. And here you will be able to see all the objects of Earth Engine. So everything is going to start with e-doc something. So you can think about it's like Google Earth Engine wrap the object and you don't know what it is until you ask for it. So you need to open it. And if you look at here, e-doc feature collection, and also e-doc geometry. And also for the geometry, we also have different types. You have bounding box, you have line, you have line, multi-line string. You're also going to have polygon, multi-polygon, point, something like that. So this is kind of equivalent to traditional vector data format. You have point, you have line, and polygon. So point, you can also have multi-point. Line, you can also have multi-line. Polygon, you can also have multi-polygon. So those are the basic type. If you need to construct something like this, you will need to actually write the syntax. So all the Earth Engine objects, if you click, you should be able to see this is so-called API reference. So application programming interface. So basically how you actually interact with the objects. If you look at this one here, e-doc geometry point and then coordinates. So if you want to create, for example, a point, and this is what essentially what you need. So if you click the Python example, e-doc point and then parentheses, and this here have two parameters. Okay, so the coordinates and also the projection. So by default, if you don't specify, it's going to use EPSG 4326. So that's basically the latitude and also the longitude. But in Google Engine, it's using longitude and latitude. So make sure that don't get confused. If you create a map, you specify the center, it's actually latitude and longitude. But for Google Engine, it's using longitude and latitude. Different mapping libraries sometimes use different conventions. If you go back to this example here that I'm showing you, right? If I create this one and then center equal to square brackets, so what's the order of the coordinate? Longitude, latitude? Are you sure? So when you create the map, what's the order of the coordinates? So this one is using leaflet, so I leaflet. So what's the center? What we usually put, for example, for the US. What's the center and the zoom level for the US? If you create a map for the US, roughly. I think I saw this before, right? Don't remember? Let me create a new one here. Okay. Map equal to gmap.map. Okay. By default, if you don't specify anything, it's going to be a global map. Okay. So if I just somehow I want the US, you'll be center equal to square brackets 40 and then negative 100. Okay. And then zoom equal to 4. Okay. Good memory. So here, what's the order? Is 40? Is it latitude and longitude? Come on, latitude or longitude? Can you have longitude latitude negative 100? So it's latitude and longitude. Okay, like I said, all the maps is latitude longitude. So 40 negative 100 roughly is like the map in the US. But if you're trying to construct a point, it's longitude and latitude. So all the Google Earth engine, all the coordinates, points, lines, polygon, eventually to come from points. But that's a longitude and latitude. So it's very different. So the number in here, it might look a little bit confusing. But this is what you need to construct. So if you want to create, for example, a new point, you can do this easily. Most of the time, you don't need to create this manually. You might use a point. So if you need to filter the data, then you will need to use the latitude and longitude. So one example I can show you here. Let me go back to, how about this? I want to find out images, landscape images that intersect, basically covering Knoxville. For example, just a simple example. I might ask you this in the quiz. Okay, so I want you to tell me how many images, Sentinel-2 images, covering Knoxville in 2022. Can you do that? Or how many landscape images covering a landscape 9 or 8, whatever, covering Knoxville? As long as you cover, you don't have to be a full cover, right? So you can actually do a polygon, or you can maybe, I say, for example, cover Knoxville, or maybe UT, okay? How many Google Earth images cover? Not UT, maybe just the building, okay? Just to be precise. Where's our building? So here, okay? Waters building, geography building, right? So tell me how many images for any. I want to ask you any set sensor. It can be Landsat, it can be Sentinel-1, Sentinel-2, whatever. How many images cover this location at a specific time period? So what's your logic? How do you actually do that? Anyone? You can draw a rectangle or maybe a point. I mean, either one's fine. So what else? What do you need to do? For example, you need to find out, right? Manually? No. There's no point of learning programming if you trying to do things manually. So what should we do, right? For example, Sentinel-2. Alright, so first how to get access to Sentinel-2? What do you need? We talked about last time, right? You just need this one, that's it. You need the collection ID and then you filter, and then you can filter bound. So I'm going to show you here exactly how I'm going to do that. It's just one line of code. So let me come back to here. I'm going to maybe the new line here. Okay. So this one is, for example, Sentinel-2, filter the date. I can do whatever date. For example, I want the 2020. Okay. I'm going to 2022 and then December 34. Or you can 2023. January 1st. So the first one is inclusive. The last one is exclusive, the start and the end. So if you want, for example, all the imagery for 2022, then use the first day of the 2022 and then the first day of 2023. So this date is actually not included. So what we are trying to do here is to filter all the images that um, are acquired last year. And then I can do another one. So filter, okay, very important. You need to make sure that you understand this. Okay, so filter bounds, and then so Google Essential is actually very easy to learn. If you need anything, you can always go to a help documentation. So here we're using an image feature collection, right? Image collection, and then the function is called filter bounds. If you where is it filter bounds in here, right? And you click, you can see what kind of things you need to provide. So here it's telling you, okay, you need a geometry, right? Then you need to think about how do I construct a geometry. You can look at the example, right? Look at here, Sentinel-2, filter date, and then to create a point, you can do intersection, but let's do something easier. So what we can do is come back to here, copy this line, and this is how you actually construct a geometry. So I can create a new one and tell it look like this. So geometry equal to e dot geometry dot point, right? Okay, it's supposed to be I think it should be a square brackets. It's missing the square brackets because if you go back to the example I showed you earlier, e dot geometry dot point, I'm not sure why it's missing. It might be very intelligent if it's just x1, but usually I would recommend just put a point just like the example I'm showing beneath here, right? So this one is longitude, latitude, okay? Make sure you understand that. And now, what's the coordinate for Knoxville, for the geography building? How do I get that? Inspect? How do you inspect? No, it's not inspect. This is Google Map. You cannot inspect. What you can do here is lower left corner. There's a measure tool, but there's a bug. I think it might jump the point. I'm not quite sure, but let's see. So I place my point here. You see, it's like jumping around. So it's actually not very good. But usually, what you can do, maybe this is a long-standing bug. I've asked them to fix, but it's not. But if I place my point somewhere else, it's a little bit close. Let me cancel it. But maybe a little bit here. Where is it? Anyway, it's annoying. But I think roughly it's roughly you get this number. I mean, it's not going to be too far away. So take a look at this one. What's the first number? Is it latitude or longitude? Latitude, right? The second one is longitude. So usually what I can do, Control C, and then come back to here, geometry, replace. But always make sure you reverse it, okay? Copy this one, Control V, paste. And that's where you actually construct the point, then you can do the filtering. Second way that you can get the point is like this. So you can, for example, this is right now the building, right? Geography building is roughly, you move it to the center of the map. And then you create a new code block. Just type map dot center on this one. You should also get the summer. So this one right now is the latitude, longitude. Again, make sure you reverse it, otherwise you're going to get the wrong answer. So this is one way. And the other way would be to just, you can draw a rectangle if you want, but I can also do maybe a point. Okay, I'm going to place a point here. This one is not moving, so it should be fine. And once you have the point, I can also do map. So user ROI. So basically whatever you draw on the map, not responding, user or USER, okay, user ROI, okay, and you run end, it should give you object, right? So this one also showing you the point, but it's not as precise. It's pretty precise here, right? This coordinates and latitude, longitude. So I'm going to maybe just use this way. I'm here. Okay, I show you 3 different ways you can get the coordinate to whatever location you're interested in, and then Control C, Control V here. You are what you place, what the last thing you draw on the map. The last, it can be a point, it can be a line, it can be a polygon. So for example, right now, if I draw this a polygon, right? So because this is the point of using Gmap is like it's interactive. So whatever you do with the map, you can get the information and you can pass it back to your program so they can do computation. So now I draw a rectangle, right? I run this map.user RI again. You see now it's a polygon, and then you can get all the coordinates. So basically, the four corners of the points. You can also use RI. I think it's RI coordinate, and one enter. This one give you basically the lower left corner and upper right corner. And this one might be useful, especially if you're trying to construct a polygon using Google's engine. You need to give these four coordinates, so it's easier, so you don't have to copy and paste one by one. So this give you all at once. But let's deal with just the point first, okay? So now we know the latitude and longitude and latitude of the geography building where we are located here. Then we construct a point, and with this, now we can use the filter bound and then just passing the geometry. So take a look at this one. Pretty simple and easy. So what you need to do, okay, I want the Sentinel-2 collection. I want the imagery for last year, and I want them to intersect covering this location, this point. Are we done? Of course, you can also filter like cloud cover or something else, but I'm just trying to show you quickly how you can get the images. So now take a look. It's done. It doesn't. Also, you need to understand when you run this code block, it looks like it's filtering or doing everything, but Google essentially does nothing. It doesn't do anything yet until you ask for it, until trying to display the images, until trying to see the result, because you're not asking for the result. But right now, you are just assign this to a variable. So you're sending this to Google Engine. If there's some error, it might not capture. So Google Engine is only executing when you're trying to display the data, when you're trying to show some results. Right now, there's nothing in here. So what we can do is really ask for it, and then Google Engine will really go to execute. So collection, for example, dot size. Okay, so this is asking Google Engine to tell me how many images in there. So collection dot size, and then one. See how many images? 148. Okay, so there are 148 images covering not the geography building last year. Okay, so if you really want, I can just collection dot first. If you just want to see the first image, for example, it's going to grab the images, and this is where it's going to tell you exactly what's the unique ID for this image, right? So if you scroll down, and it's tell you how many spectral bands, what's the property, also the date, right? So this is 2022 January the 4th. Then you get one imagery, right? But there are 148 images. You can certainly see them all at once if you want, but this is how you get images. This is kind of like you go to USGS, the data source data portal, and then you select what data you want. You specify the start and the end date, and then is draw whatever area you like, and then get the images. And then you can click the thumbnail, you can look at that. But still, if you want to do something, you need to download the data. So it's not very convenient. But this one, it can give you tons of images. So next, I'm going to show you here, maybe they say, okay, I want data covering, for example, all the UT campus, because it's one point. It might have an image that just cover a small section. So in this case, I can simply do this. Okay, I can just draw a rectangle. Okay, and you can, oops, I think there's also a bug. So if you press escape, it's just return. So draw a rectangle. So now I can do something similar here. Everything else remains the same except the geometry. So now the geometry, you can do bounding box, or you can just simply do this map.user RI. Okay, basically we're filtering based on the user RI. So take a look, run this one again. Size, it's probably going to be more than 148 because we increased it. Oh, it's still the same. So that means most of data is actually covering just but if you increase much larger, then definitely it's going to be a whole lot more. But for example, entire Knoxville, oops, escape, and I bet it should be larger than 148. Otherwise, I will stop talking. You see, 595. So that means there are a whole lot more images available. So let me return back to the previous one here, just using the point. And so once you have the images, how do you actually visualize that, right? So you can, 148, you can use the first imagery. So here, once you have this one, you can certainly, I can assign this one to available. So image equal, okay, to the first image. And then I can just type map dot add layer, okay, image, curly brackets. Right now, I don't know the band names yet. You can just specify the empty string and then first image, for example. Run this one. So like I said, Google Search Engine doesn't execute until you add the images, you display it, you ask for result. Otherwise, it's just really fast, just sending a command. It's just like a placeholder. And now let's come back. Ooh, you see, we have the image now. Why it looks like this? Let me clear the all the RI. What is this doing? Why is it like all black? Is it all cloud? Huh? And like I said last time, this is where you can actually figure out if you're familiar with the satellite, you already know the band, the value range this perfect. If you don't know, you can always use the inspector to see the band. I hope there's no bugs, but you can. Right, so take a look at this. So by default, it's going to use the first three bands, and I think the problem is this one. And most of the value range from like couple thousand to I think 10,000. So what you can do is to specify the spectral bands you want. For example, B4, B3, and B8. Right, so there's the first color composite. So I can come back to here, I can redo it, or I can add a visualization parameter, just like what we did last time here. If you recall, right, I can just copy this one. So you can specify the minimum, the maximum, and also the spectral band, right? So B4, B3, B2, 3000, and then passing to here, VRS, and this one again. So hopefully it should look much better. Okay, it's still, it's what's this?
Your image now is only a first band.
No, this is always three bands. So this one right now is just three bands. So if you come back to here, um, in the image is three bands. It's not just first. You probably see the color, right? Now you can see the color. So this is basically, I think it's it should be no. So the reason why it why it looks like this. Why is it so? Oh, because of what? No, it's probably snow because in January, right? And that's why it looks like this. But you can select other images. For example, this redo this one. Okay, I want to maybe select images for. Let's start with July. Okay, so usually summer is going to be much better. So I'm going to do the dry and see how many images in there. Okay, now I grab this first image and then run this one again, run this one again. You should see a much better imaging. Okay, now what? Cloud. So how do you filter cloud? You gonna do it last time? Yeah, you can do the medium. You can do the medium. You can create a medium, or I can just filter, uh, add another criteria. So I'm gonna filter the data. I'm gonna come back to here. I just hit enter and then replace this one. So now we are not only finding images, but we are finding cloud coverage less than 5%. So this is going to give you a whole lot better images, but you're going to end up with only a smaller one. It might be 0 or okay 7, so that's good. If this like the number is too small, you're going to end up with a smaller number of images. So for now, let's run this again, and I can guarantee you, you're going to get a better. Oh, still not good. Yeah, run this one. I hope it's much better. Take a look. How nice. There's still some a small cloud here. If you want, you can lower this number again. Maybe let me see, 2%. But I'm not sure if you're gonna get something or not. Okay, nice. You still have 6 images. That means I can follow decrease. Okay, just 1%. That means you're going to probably get, okay, much better images. So run again, run again. See? So now you have a pretty much cloud-free images. For the not free, where's UT here, right? No, it's because each image has the metadata showing you what's the cloud. So it's basically do the filtering. If this image, the cloud is less than 2%, I select it. So if you look at here, earlier we used the first image, right? So if you want to see the metadata, I can just type here, image, and then just run it. So this is going to print out the variable. It's going to show you all the attributes associated with the image. So if you click here, property, and all the bands, right? So this is where the cloud cover, 0.0000518%. So it depends on your criteria. The more criteria you have, the less like the smaller number of images you're gonna get. So this is how you filter the data, get a cloud-free imaging for anywhere you like. So now think about here. This is for Knoxville. Can you do it for somewhere else? It's just a piece of cake. You can do it for like, for example, how about this, San Francisco, right? Now come back to here. What I need is just very simple. I can just do a rectangle, something like this. You might get multiple, but let me do a smaller one. So basically within the city, so that you don't end up with some images near the ocean. So I can maybe try somewhere here. Okay, and then everything else pretty much the same, except now I can change it. You can get, of course, you can go to get the coordinates, but for me, I will usually just use map.user RI, and that's it. So run this one. See how many images in there? 5 images. It's coincident, but it's, and run this one again. Run this. Take a look. How nice. Isn't it easy? You don't have to download. Like you have the images, and it's very high quality. Take a look at this. Like for 10-meter resolution, anywhere, any country, any location, as long as I have the imagery. So let me clear this up. And not just for one images. So later on in this course, we teach you how to do time series. Right now, I'm only getting the first one, but at least you can visualize that. You can see what you like. Change the opacity. And you can change the data layer. You can do a lot of things with those imagery. So this is essentially you go to the data portal and trying to do the filtering, select the imagery you want, and then download the imagery to a computer. But now you are actually seeing it. Kind of like in the past, you go to the theater or go to the store and then Walmart, try to buy the DVD and take it what you like, and then bring a bunch of those back to the back home and then just open it and then try to watch it. But now, like YouTube or Netflix, search, see it. If you don't like it, change another one. Let's say like, oh, I want to watch a romantic movie today. Okay, Valentine's Day, and then you try this one. Oh, it's not working. I don't like it. Let's try somewhere else. Okay, you can try any other location. You can try any time period. Okay, they say, okay, I want image in the 1980s. This one doesn't have the 1980s. Starting from 2017, so you can actually, these are things are all customizable. So you can do whatever. Not just the cloud. You can also filter, for example, specific day, specific location, specific time, and okay, you can filter any attribute that's in here. So if I scroll down properties, you can do, for example, the quality, the ID, also mean sensor time and radiance. So basically, these are things that all you can use to do the filtering. Okay. Yeah, you can do the filter by setup, but the setup is already fixed by this here. This ID already tells you it's Sentinel-2. But you're welcome to change it to let's say 8 or 9. Okay. The only thing you need to figure out is what's the unique ID for this one, and then say 8 and 9 they don't necessarily use the same um, attribute. So here, if you really want, I can maybe go here and then go to the or you can source directly using Gmail. But I'm going to showing you the original way if you want to figure out. So come here, data, and then or you can search it, or I can just go to here and then scroll down. So they say, okay, now I'm interested in using lens data. Okay, so I'm gonna come back to here and okay, this one it's working too fast. Is it okay? Data set, and so scroll down here, find the lens data, and so do you have 987? So I'm going to look at the first, the latest one, lens at 9. And usually you want to use the surface reflectance, so means it's already uh, uh, has the atmospheric correction, so the data quality is pretty good. Then this is where you actually see things. Okay, this is the idea. So what you need is this one, and everything else pretty much remain the same except the cloud, because it might use a different property, but the date and the location are pretty much universal. So here, what did I copy? Is it this part? And then right paste. But now, comment out this one, because um, the cloud it might not use this one. So what we can do usually is just again, for example, I'm gonna draw a rectangle here around San Francisco, and so if I run this one, see 21 images, and I can do the same thing. Okay, I can run this and look at what attribute it used to do the cloud cover. So I'm going to go to properties. Look at this one. This one is called cloud cover, and then cloud cover lens. So it's a bit different, depends on the sensor. And what we want, for example, if you just want a cloud cover on lens, specifically, I can just Control C, and then come back to here, Control slash, and paste with this one. Okay. So this I want a cloud cover on lens less than 1%. Let's see if we get anything. Okay, nice. We still have 4 images. Okay, and now I don't need to run it. I'm just going to directly come back to here because I already specified. Right? Oops. Oh, because there's no B8, I think. So you need to maybe uh change it to a smaller number. I mean, maybe just B4. I think it's SR, the band values. So you need to make sure that here, come back to the attributes and then see the band. So this is called SR B1, B2 or something like a B4. So you need to make sure that you use the same one. Otherwise, it's not going to be able to do that. So I'm going to just use SR. Okay. And then again, SR. SR. Let's go. Then you should be able to see the imagery. Okay. I'm back. Oh, what is this? Oh, okay. Yeah, no, but what happened? It's all white. Okay, again, it's just the value you use to visualize. So I'm gonna come back here again, and I took it the value, like it's from 1 to 2 to the power. I think it's what's the number? 6, 16, right? 16 hex code. So you need to have the number much larger, because if you look at the example here, oh, they do the rescaling. So if you really don't know, again, you can always use this inspector to see the pixel values. If it is too much, your visualization value is too low, then it's going to go all white, right? Because all the value will be larger than, most of the value will be larger than 3000, right? Because this is, we use to visualize the Sentinel-2. So this 3000 is way smaller than in here, right? Most of those like 30,000 or something like that. So you need to specify a much larger number. And how about maybe 40,000? And run this again. So this is sometimes you need to do some exploration, right? Nice. Why the image looks so bad? It's not supposed to be. the cloud cover less than 1%. Oh, because I forgot to run this one. Okay, we'll run this again, and now it should be a very cloud free imaging. Take a look. Although it's a bit dark, but you can maybe lower this value. It's to be better. So maybe change to how about 30,000. It should be brighter now a little bit. Right? So this is how you filter the data. Now, if you need to find any satellite imagery, this is the way to go. Right? You can just specify where the location you want, the time frame, and if you have some additional attributes, you just do that. That's that easy. So now you don't have to go online to download any data, and you can change it to other locations because we changed from a Sentinel-2 to Sentinel to Landsat. So I have to adjust some parameters, the cloud cover name, and also the visualization maximum, minimum, and also the bank name. But if you're just doing the Landsat 9, how many things you need to change if I'm just change the location? How many lines of code you need to change? Where? Wait. For example, I want to right now. I want to find images for uh, another location. For example, Las Vegas. Right. So what things need to be changed? Right. You can do latitude, longitude, or like I said, the easiest way would be just draw a rectangle, and then filter this again. You can get the first one. I can show you how to use other images later. But for now, we just run this one, run this one. Okay. Of course, it's your area is like much on the to the right side. So if you want the urban area, let me remove it. Okay, so just focus on this area, or you can just a point, so then you can get another images on the left side. Okay, run it, run it, run it, run it. 10 images. Okay, now you have the images. So this is why it's so powerful. If you once you figure out the workflow, try to make your source code as efficient as possible. So if you need to change the location, you need to change the time period, you only change 1 to 2 lines of code. Everything else remain the same, right? So this is the power of using programming to automate things. For example, I want to find images for the top largest city in the US. As long as you have the name, you have the coordinates for each city, just looping. Right now, we're just doing just one. So later in this course, we talk about how we can do time series. So we can get as many images as you want. And you can do the same operation. So right now, we are only simply visualize data. This is the most basic one, is to look at the data. But what kind of things you want to do with the data is another whole, like a lot of things you can do, okay? So this is like essentially what you need to understand is load geometry. So right now, we're using just the point and the line, and there's also rectangle. So rectangle here is where you passing the coordinates. So again, make sure you understand this one. So it's minimum x, minimum y, maximum x, maximum y. So it's basically the lower left corner and the upper right corner. So this one here, x, okay, x is like vertical. So x, is it latitude or longitude? X, what's x? Longitude, okay. Y is horizontal, is latitude. So you'll be longitude on the lower left corner. So you'll be where's this rectangle? Probably it's too much in here. I think I can comment out other stuff so that it's easier to. Let me comment out other polygon and comment out other points. So it's confusing. Just the rectangle. Because most of the time, you can just construct point and rectangle. I think there's the two ways you can do. What? Oh, because of this, I enter this one, but I did not do anything here. So I'm just create an empty map and then create a rectangle and then display it. So look at this one here. So we create a map, we create a rectangle, and this is negative 40, negative 20, positive 40, and then positive 20, right? So look at this. Why the rectangle looks like this? Because by default, there's a parameter. So if I go back to the Earth engine documentation, let me show you once again. So anytime if you need to do something, you always can check the references because everything is constructed based on the API. So if you go back to geometry, and then go to the what do we use? Rectangle. So rectangle here. Take a look at this. Right. So the coordinates, the projection, also the geodesic, and also event and all. So here, by default, if you don't specify, it's going to use EPSG 4326. So basically, it's just longitude and latitude. But you can also specify the projection, but the number will be different. And there's also another parameter here. Geodesic means by default, the distance is based on the globe, not based on the flat map. And that's why if you look at the map in here, it's not uh, rectangular line because this line is actually basically giving me two locations, giving me two points, and then you draw a line. It's drawing a line on the globe. It's not drawing a line on the surface. So if you go into the globe and you project it to the flat map, is actually a line, is a curved line. So this is basically, think about the great circle line, something like this. Is the shortest distance between any 2 points on the globe. Okay, but if you really want a rectangle one, you will need to specify force. So basically, you this one you don't specify, you can prop a none and then equal to force. Then it's going to be a rectangular. So in that way, you will look at this. So let me come back to here. Where is it? Rectangle, coordinates, comma. So none basically means that projection is none. Like if this none by default, it's going to be EPSG 46. Okay, so run this one again. See? So now it's a rectangle. So on the map, it's rectangle, but this is not the shortest distance between these 2 points. Okay, so it's going to be much longer than the great circle. But if this is something you want, you specify. Okay, so the geodesic parameter is where you control whether we want to create a geometry based on the flat map or you want to create a geometry based on the globe, the 3D. And so now if I'm asking you, right, based on this, how do you create a polygon covering the continental US? Because you can be doing some research, you want to get all the images covering the US, right? But in order to do that, you need to have the area, right? You need to figure out where is the rectangle. So how do I get the rectangle for the US? Can we? Okay, yeah, that's it, right? Just use the rectangle too. I can just draw here. And once you draw this one, you can get the coordinates, okay? So if you come back to here, map dot user RI, you can do this one. So by default, it's going to be a polygon object, but still, you need to copy all the coordinates, right? So this is lower left corner, upper right corner. So take a look at this one, right? So this is the longitude, and this is the latitude. So 21.31, and so this one is the same, and then 51.63. So tell me, where is this coordinates on the rectangle? Which corner? Yeah, southwest. So it'll be here, this point, right? So this is the longitude, so negative 130, and the latitude will be 21, right? Because you're going north, the latitude will be increased. And how about this corner, this one? Okay, northeast, because you'll be the longitude will be on the right, so it's much larger, and then also the latitude will be in the upper right corner, so it should be this point. So essentially, what this is doing, so you have 5 points although we draw a rectangle, it's in Google saying it's transform into a polygon. So you be 5 points, 1, 2, 3, 4, 5. So if 5 point is going to close, so the last point is the same as this one. So this is how we can get the coordinates, and then you can use to either rectangle, but usually what I do is just underscore and then just coordinate parentheses, and this one is better. So southwest, northeast. So x min, y min, x max, y max, and this is where you can construct the polygon. And then I can say, okay, Ri equal to e dot geometry dot rectangle parentheses, and then so the rectangle you need to pass in basically is a list, okay, something like this. So now I can just do here, Control V. Oops, no, this one. We're gonna grab this one I just draw, and then passing here, okay, and then none. So basically just no projection, just the coordinates, and then equal to fourth. So that means I just want a rectangle. I don't want something else. And once you have this, then I can just map to add layer. Okay. So then it will be RI. I don't need to do anything else. And then so this one I can just give a name, for example, US. So take a look. Run. Oops. Why is it kind of shifted north? Is the number wrong? Interesting. It's not supposed to be. So it's to be exactly the same. There might be some bug in during the composition. I think the latitude is way too high. So here I can change it maybe to how about 50 maybe. Okay. Run this one again, run this one again. Okay, you see a little bit better. So this is how you can get the coordinates. And you want to do this one because you can use the drawing tools to draw something, but you will want to have something reproducible. You want to have that in your code. So when other people run this one, you get the same result. Otherwise, you're asking people to draw a rectangle. Sometimes there's no data in the rectangle, or people might, you cannot draw the same exact rectangle every time, even if it's yourself. So one way you can do is to first try it out yourself, and then get the coordinates, and then figure out what you want, and then make adjustment, and then put it into your source code. So next time when people run your code, they're going to get exactly the same result. So this is the recommended way to do stuff. Okay, we are out of time. So make sure you practice how to construct point line, polygon, and how to use that to filter data. And if you have that, now you can go online to get any data you want. Basically, now you can go online to watch any movie you want. Right? Date, time, the name, whatever, because the workflow will be the same. Okay, so that's all for today. I will see you on Friday.